All right, we're going on to a test of Chapter 3. Form A is the one we're using. And again, we're looking for strategy, a quiet area, focused, reflecting on what tools you have in your own little toolkits. And we're asked to graph this particular linear equation. Now, notice it's not in any particular form. So I think what I'll do is solve it for y. So I have 3y right there. I'm going to have it equal to x. This is what I had. I just wrote it a different way. And then I'm going to take this -6 from this side and bring it over as a +6. Now I'm going to solve it for y by dividing everything by 3. So I then get y equals 1/3 x plus 2. Now in your toolkit you ought to have a number of ways to solve, and what's obvious here is we can use the slope-intercept form to graph this. So the first thing we do is we plot the y-intercept, which is a +2 right there. Then we look at our slope, which is rise over run. It's positive, so my run is 3. 1, 2, 3. And my rise is 1. So I can put in 1, 2, 3, rise 1. I get a couple of points here. Okay, now I take my line tool, and there's my graph. Now in example 2, as we look at it, we see that example 2 is in standard form. And we're saying the tool to use when it's in standard form is to make a little t-chart. That special x and y intercept t-chart, where there's the basic form. You put a 0 there and a 0 there. And then we're going to solve it for these letters. If this x is 0, this becomes a 0, and we're going to divide both sides by a -1, and we get y is 2. And if y is 0, we're going to divide both sides by a 2. This is 0. This becomes a -1. Now, this gives rise to something, and I'll do a little review here. When it's in the form of 0, b, this is your y-intercept, where the line will cross the y-axis. So 0, 2 is right there. And this form is a, 0. That is your x-intercept. So -1, 0 right there. So it looks like over 1 up 2. So get a couple of points here. Over 1 up 2. Okay. Take my line tool now, and there we go. Now, with your math lab, they're very easy to graph. But let me point out something now. Right here, that is your y-intercept. And right here, That is your x-intercept, where the graph will cross the lines. Now there's other tools. You could have used a t-chart over here, put various points, but I think the best way, or one of the ways I would suggest, put it in slope-intercept form when it's like that. You could have also used the X and Y t-chart by putting the Y over on this side, putting it in standard form. But again, that's the choice. As you've practiced, hopefully you've developed some methods to do this. Let's go on. Now, as we look at example 3 is already in slope-intercept form. And you recall that one is y equals mx plus b, where this is your y-intercept and this is your slope. When you solve for a positive y, so our y-intercept is a positive 4. So 1, 2, 3, 4, a dot right there. Our run is 3. It's positive, so 1, 2, 1, 2, 3, up 2. 1, 2, 3, up 2. We're just getting a few more lines here so that we can sketch that right in there. All right, so again, it's easy if you have a technique to do it. Now, for this next one, this is a special case where it's in the form y equals b, and this happens to be a horizontal line going through the y-intercept at 2. So we just put a dot there and another dot in the other place and make our line. And there's the graph. Now, the slope of this, by the way, if you recall, let's just write that out as a review. M is 0. The slope of any horizontal line is 0, and the slope of any vertical line, maybe they'll give us one, is undefined. All right, just a little review. Now for number 5, they're asking us to find the slope. And as we look at it, you may recall again that any line that starts high and as it goes this direction is negative slope. It starts high and goes down from left to right, negative slope. So we know this is negative slope. And let's see what we can do here. Now this is they're saying is, let's put a few more lines in there. That'll be like so. Okay, so how many units up do we have for our rise? We have it up there. 1, 2, 3, 4, 5, 6, and 1, 2, 3. And we said it was negative. So our slope for this is going to equal a negative 2. Now, let me just go back and look at it to what it was originally here. So this was 1, 2, 3, if we just did it that way. And this is 1.5 here. That's why I put some extra marks in there. And that is still, again, negative. That's a negative 2. That one's a little tricky. Okay, we're asked to Again, find the slope for all of these. And for number 6, we have to use the slope formula. Y sub 2, which is 5, minus y sub 1, which is 4, x sub 2, which is negative 6, minus a negative 2. So this we know will become a plus. So on top we have a 1, and on the bottom we have a negative 4. So our slope for number 6, and we would often put the letter m there, is a negative 1/4. Now, when we see something like this in standard form, and they're asking us to find the slope, the best formula for that is the slope-intercept. So I'm going to solve for a positive y. I'm going to bring the 3 over. Now I'm going to divide everything by 2. So I get then y equals a negative 3/2 x plus 3. So my slope then is right here. M equals a negative 3/2. How did I get it? By solving for a positive y, putting it in slope-intercept form. Now we just had this one for number 5. Y equals b is a horizontal line. The slope of a horizontal line is 0. Again, they want us now to find the slope and the y-intercept. Again, this is standard form, so we'll solve it for y. Transpose the 2x to the other side. Becomes a negative 2x. Now my slope is a negative 2. And my y-intercept, remember the official way of writing that is the y-intercept is 0, 3. But I believe in our lab, when you do it, and you'd have practice of this when you did your practice in Quiz Me, is they just want you to say a 3. They don't want it in this official form. They'll just say B is 3. I think I recall that. All right, let's raise it up a little. For number 10, they're asking to determine whether these lines are parallel, perpendicular, or neither. And again, the strategy is solve each of these for y, because our slope here for this one is 3. So here we have 3y equals a negative x plus 9. And I'm going to divide everything by 3. So this is y equals a negative 1/3 x plus 3. Now we're going to compare our slopes. Slope of this first one was 3. The slope of the second one was a negative 1/3. Now, are they the same? No, so they're not parallel. When we multiply these slopes, do we get a product of negative 1? And the answer is yes, because 3 and negative 1/3, this is the negative reciprocal of 3. When you multiply the slopes and you get a -1, the lines then are perpendicular for number 10. And we have the proof right there. Okay, find the equation of the lines, put it in standard form. Now it has the slope of this, and it's going through this. Okay, so again, what strategy can you use to find this? Well, we need to use that special y minus y sub 1 equals m times x minus x sub 1 formula, which is called the point slope form. So we're first going to put our slope in there, which is a -1/3. Our x is a -2, so x minus, which is in the formula, a -2 makes this a +2. And then our y, and then our other y is -4. And we have substituted now. And the key is to remember this formula. Now, you want it in standard form, and standard form doesn't have any fractions. So the first thing we're going to do is get rid of all our fractions here by multiplying every term by 3. So this becomes then 3y minus 12 equals, here the 3's cancel out, and it's just opposite signs, -x, -2. Now we transpose this. A -12 on this side becomes a +12. 12 minus 2 is 10. We transpose this -x to this side. That gives us a +x. And there we have this with this slope going through this point in standard form. And that was my procedure. For number 12, going through the origin and having this point. Okay, so again, we're going to use that same form here. Y minus, we could put there this one, and it's going to become minus a -6 makes it a +6. And I'll have to pause there for a moment. Well, I had to figure out the slope first because we didn't have the slope here. So our going through the origin, that's your other point, 0, 0. And then this point, 5, -6. So putting it in the slope formula, y sub 2 is -6 minus 0 over 5 minus 0 gives us a slope of -6/5. And then we put it in the point slope form. Y minus a -6 gives me a +6 there. There's my slope, and x minus 5 is this. So again, we want it in standard form. So I'm going to multiply everything by 5. This helps get rid of all our fractions here. This is just one term. So this becomes 5y plus 30. Here the 5's cancel out. Now we have to multiply through. Equals a -6x. And this is a -6 times a -5 gives me a +30. And we're left then with Moving this to the other side, that gives us a 0 there, which is what we would have expected. And this becomes 6x plus 5y equals 0. That's for number 12. And again, some of these are a little bit tedious, and you have to read it carefully. So here we have this. I'll take you through the whole thing. It's going to be 2 minus 5. We have to find the slope first. 4 plus 3, because there were two negatives there. This becomes a negative 3 over 7. So negative 3 over 7. Let me just check my work. 2 minus 5, 4, minus a minus 3 makes it a plus 3. Yes. Okay, so now we can use either point, and I'll use this one here. So y minus 2 equals a negative 3/7 times x minus 4. Okay, we're going to multiply everything by 7 to get rid of our fractions. So that's 7y minus 14. Here these cancel, equals a negative 3x. Let me put it there, it's a little better. Negative 3x plus negative 3 times negative 4, 12. I'm going to bring the negative 3x over as 3x plus 7y. Now when I bring a negative 14 over to this side, it becomes a positive 14. And this leaves me with a 26. Okay. Now for number 14, again, strategy. They're telling us the slope, and they're telling us the y-intercept. So we can just use this y equals mx plus b to write this formula out. We get y equals, our slope is 6, and our y-intercept is a negative 3. But they want it in standard form. So I'm going to have to transpose that. So it becomes a negative 6x plus y equals a negative 3. In some textbooks, they wanted your x term to be positive. So an alternate of this is just to multiply everything through by a negative 1. This would then become 6x minus y equals 3. These are equivalent, and our book does accept it this way. Okay, let's go on. I see this is going to be a little long. Now, for these, we are asked, are they functions? Let's raise it up just a little bit more. And again, what strategy would we use here? Well, you may recall we said there is something that's called a vertical line test. These are my vertical lines, and what I'm going to do is move these lines over the face of the graph. Now, as this red line goes over the graph, does it intersect this line in more than one place? And the answer is no. So we say it's passed the vertical line test. So yes, this is a function. Now this is a parabola. As this vertical line passes over, Does it intersect this parabola in more than one place at a time? And the answer is no. So this passes the vertical line test. And these are functions, both of them. Now for 17, 18, and 19, they're giving us this function up here, and we're asked to give a value for them. Well, for something like this, we could put it in a little T-chart format, where remember this can always be substituted for a y. And our x value here would be a 1. Here it's a -2, and here it's a 1/3. So as we set it up, we put our values there. Now we're going to substitute. 1 goes where the x is. 1 squared is 1. 3 times 1 is 3. Minus 7 is a -4. Now 3 squared is 9. I'm getting ahead of myself. 2, a -2 squared is a +4. 3 times 4 is 12. Minus 7 is 5. And this next one can be confusing. So 1/3 squared is 1/9. Now 3 goes into there once, this goes into there 3 times. So I have here 1/3 minus 7. Well, in order to do that subtraction, I have to convert this to something that are thirds, which is a -21/3. Now I end up with a -20/3. And once again, we're squaring 1/3, which gives me 1/9. 1/9 times 3 is 1/3. Then 1/3 minus 7 over 1, which becomes a -21/3. This is another form of 7, but with common denominators, I get a -20/3. Okay. Okay, they're saying use this graph to solve these problems. First of all, find the domain of this. Well, domain, you may recall, are the x values. And this is going this way, and this is going this way. So eventually, this line goes all the way out there to -infinity, out this way, and this way for x values to +infinity. So the domain in interval notation is from -infinity to +infinity. Now the range of this are y values. And this is coming or going down to -infinity down here. So it's coming from -infinity, going up this way, and goes all the way up to right there at 1. So we put a comma, a 1, and since 1 is included in the set, we use a bracket. Now for the domain of a function, it's what would make this denominator a 0. So what we do is we say 2x minus 1 equals 0. So we solve for solve for x by removing the 1 to the other side, becomes a +1. We get x equals 1/2. So if we put a 1/2 for the x here, that makes this denominator a 0, because 2 times 1/2 minus 1 is a 0. So for our domain of this function, we say x can be any real number, but x cannot be 1/2. And in interval notation, that would be from negative infinity up to 1/2. 1/2, it stops just before 1/2. Then we have a union with 1/2 the other side of it, and then it goes to positive infinity. Okay, well, we're almost finished, but we're up to 30 minutes here. And your test is not going to be this long, but a good review. Now, the following graph shows the height of the ball in feet thrown in the air by a small child. How high is the ball after 2 seconds? Well, 2 seconds, it's 4 feet. What is the approximate height of the ball at its highest point? Would you go for 4.5 feet? And I'm going to have to raise it up here. After how many seconds does the ball hit the ground? Well, it hits the ground at what? 4 seconds. Okay, so that one was easy. Well, again, lots of stuff. Get your practice and quiz me's done so that when you're ready to take the test, you know your stuff.